Assalamualaikum Assalamualaikum warahmatullahi wabarakatuh and good evening. Today we are going to present our mini project called carbon dioxide gas leakage detector. Here with me our group members from myself, Muhammad Ajazuddin alias Muhammad Afiq, Ahmad Fahan Bushari and Muhammad Shadi Zakwan. Wait. So this is the view of our project, the glimpse of our project. So our lecturer is Madam Farhana bin Mokhtar. Okay, let's dive into introduction. This project is called gas leakage detector system. This project is created to monitor carbon dioxide presence employing gas sensor, a control panel and an alarm. The sensor identifies specific gas and send signal to the control panel, triggering alarms to alert occupants. Crucial for safety, this system prevents hazard by detecting leaks. Additionally, smartphone software enhance preparedness by providing remote monitoring and alerts.
Okay, for general overview, the gas leakage detection system integrates an TF robot sense 0219 OLED screen, buzzer, and a GSM module, controlled by Arduino microcontroller programmed in embedded C++. It provides accurate and rapid gas leak response. The system displays gas concentration levels on LCD, emits audio alert via a buzzer, and use LED lights for visual indications. The inclusion of a GSM module enables SMS alerts and calls to users, ensuring remote notifications regardless of their location during a gas leakage event. Specifically designed for UNKL MFI welding workshops safety, it offers a cost-effective, portable, and precise solution for industrial and domestic applications.
So the objective of this mini project is of a carbon dioxide gas leakage detector is to reliably sense and alert the presence of CO2 in enclosed spaces to prevent safety hazard or equipment damage. It continuously monitors air quality using sensor, triggering alarm when CO2 levels surpass that threshold. The detector aims to be sensitive to various CO2 sources, durable in harsh environments, user-friendly in installation and operation, with clear maintenance instruction. It should be compatible with a HVAC system, refrigeration units, and industrial process while remaining cost-effective. The ultimate goal is an efficient solution that minimizes false alarm and process interruptions.
Yes, so we're going to we have 10 type of justification on why the system need to be integrated with IoT.
Okay, so the first one is to enhance the safety through immediate detection. IoT, Internet of Things, allow for the instantaneous transmission of data. So when a CO2 leak is detected, the system can instantly alert the personnel or trigger safety protocol. This immediacy in communication is crucial for preventing harm, as prolonged exposure to a high level of CO2 can lead to health issues such as headache, dizziness, asphyxiation, or even fatality in extreme case. Next one is the remote monitoring and accessibility. IoT also enable the monitoring of CO2 level from any location. Facility managers or safety personnel can check the status of the room or area without having to be physically present. In the event of a leak, they can take immediate action such as activating the ventilation system or alerting the staff, all from a remote location.
The third point is predictive maintenance. With continuous data collection, IoT-enabled system can be used historical data to predict when maintenance is needed before a malfunction occurs. This predictive approach can prevent downtime and the potential for leaks, ensuring the system operates consistently without interruption. The next one is integration and automation. IoT allows the CO2 detector to be integrated with other building management system. For example, if high level of CO2 are detected, the system could automatically increase ventilation, shut down certain operation, or close off affected areas to prevent personnel from entering.
Okay, next is data analysis for improved response. By collecting and analyzing data over time, the system can identify trends and patterns in CO2 levels that may not be apparent during manual monitoring. This can help in understanding the root cause of leaks or identifying areas that are more prone to leaks. Okay. The next is effectiveness. Although the initial setup for an IoT integrated system might be higher than a standalone detector, over time, the operational cost can be lower. Automation reduce the labor required for monitoring and maintenance, and the ability to prevent incidents can save costs associated with health impacts, regulatory fines, and repair.
Next point is a regulatory compliance. Many industries are subject to strict regulation regarding gas emissions and workplace safety. An IoT integrated system can provide accurate and timely reporting that complies with these regulations, reducing the risk of non-compliance penalties. Number 8, scalability and flexibility. As, facility, as facilities grow or change, the detection system must adapt. IoT makes it easier to add more sensor or change the configuration without significant rewiring or manual intervention.
Number 9 is the environmental stewardship. So by preventing or quickly addressing CO2 leaks, organization can demonstrate their commitment to reducing their carbon footprint and contributing to environmental sustainability. And for the last one is the user-friendly interface and notification. IoT system often come with user-friendly dashboard that provide a clear view of all monitor condition in real time. So notification can be tailored to the preference of the user, ensuring that alert can notice and act upon quickly.
Okay, so everything comes with their advantages and disadvantage. For this project, we conclude we have 7 advantage and 7 disadvantages. So the first advantage is early identification, security, constant observation, system for automatic shutdown, flexibility, low upkeep, and connectivity to building management system. For the disadvantages, and inaccurate alarm setting price might be higher, limited range of detection, reliance on authority, maintenance requirement, restricted gas type, and sensor lifespan.
Okay, the next slide is application of gas leakage detector. There are several uses for gas leak detection in commercial, industrial, and residential environments. Their main objective is to detect and notify people when there are gases in the environment that might be hazardous or flammable. The following are a few typical uses. Okay, the first one is residence usage. The first point is home safety. Since natural gas, methane, and propane are frequently used for cooking, heating, and water heating, gas leak detection detectors are frequently used in a house to keep an eye out of leaks. Residents are given yearly notice of potential gas leaks thanks to this device. Okay, the next point is offices and workplace in commercial buildings. Gas detector are utilized in commercial areas to keep an eye out of natural gas leaks or other gas leaks related to heating or industrial activities. Okay, the third one is restaurant and cafeterias. Okay, natural gas or propane leaks for cooking appliances are found in the kitchens utilizing gas detectors. Okay, the last point is laboratories. Gas detectors are used in laboratories that employ gases for industrial operations or experiments in order to protect both the staff and the building.
So next one is for industrial uses. So the first one is chemical plant. Gas detectors are essential for keeping an eye out for dangerous gas leaks that might endanger both the facility and its employees. Number 2 is oil refineries, where different gases are handled and delivered. Oil refineries utilize gas detector to keep an eye out for flammable gas leaks. And the last one is gas detector are used in power plants to keep an eye out for any leakage of gases that may be utilized as fuel, such hydrogen or methane.
And the last one is the mining sector. So the gas detector are essential for guaranteeing the safety of mining in gold mine, where there is a significant danger of methane gas leakage. So they can provide an early warning of any leak.
In agriculture environment, also we use the carbon dioxide gas leakage application, which is used for livestock farms to safeguard the health of farm workers and animal alike. Gas detectors are employed in places where chemicals such as ammonia may be present. And the second point is greenhouse. Gas detectors assist make sure that concentration stay within acceptable bounds in areas where carbon dioxide is utilized to promote plant development.
Okay, the last is transport. To identify leaks and avoid possible collisions, gas detectors are installed in propane or natural gas-powered vehicles, such as buses and trucks.
So next one is research and laboratory facilities. So gas detectors are used in laboratories that handle gases in order to protect researchers and maintain the integrity of studies.
Next is for the plans for treating waste. So it is to keep an eye out for of the leakage of gases produced during the treatment procedure. Gas detector are used in wastewater treatment facilities.
In this project, we have both software and component integrated into our mini project. So this is the system overview. First one, we use Arduino Nano as the microcontroller. So this microcontroller based device with 16 digital pins that can be used for various purposes. It can be used for almost every task from minor to massive industrial scale project. It can be it can also be used for prototyping and developing new application.
Okay, the second component we use is Wi-Fi module ESP8266. Okay, the module enables microcontrollers to connect to 2.4 gigahertz Wi-Fi using IEE. It can be used with ESP80 firmware to provide Wi-Fi connectivity to internal host MCUs, or it can be used as a self-sufficient MCU by running an RTOS-based SDK.
The next component is buzzer sensor. So buzzer sensor is used for generating sound. It is a digital component that can be connected to digital outputs and emits a tone when the output is high. Alternatively, it can be connected to an analog pulse with modulation output to generate various tones and effects.
So the next component is the DF robot SEN0219. So the gravity analog infrared CO2 sensor for Arduino is a high performance sensor that combines technology of mature infrared absorption gas detection with precision optical circuit design as well as sophisticated circuit design. This is a 0 to 5,000 ppm CO2 sensor with analog output. It supports Arduino and other microcontroller with ADC function.
And the last one for component, we have 1 inch OLED display module. Growth, this OLED display is an OLED monochrome 128 64 geometric display module with growth 4-pin L2C interface. The characteristic of this display module are high brightness, surf emission, high contrast ratio, slim outline, wide viewing angle, wide temperature range, and low power consumption.
Okay, this is we use for our the next one is Arduino IDE. Okay, contains a text editor for writing code, a message area, a text console, a toolbar with buttons for command function, and a series of menus. It connects to the Arduino hardware to upload programs and communicate with them.
1 inch OLED display module. Improve OLED display. Dah ada tadi kan? Next. Smart gas leakage app. So this app we can use in a smartphone that connect using Wi-Fi that have been setting to monitor the gas leakage.
So here is the flowchart for our system. Slide. And here is the process and activities offered by the proper system. The first one is the real-time CO2 monitoring. The system utilizes a non-dispersive infrared sensor to continuously measure and monitor CO2 level in the environment. This real-time monitoring ensures that any change of anomaly in CO2 level are promptly detected.
The second one is alert and notification system. The system is equipped by an alert and notification system that instantly notifies relevant individual or personnel when a CO2 leak or abnormal CO2 level is detected. This allows for immediate action to be taken and minimize the risk of potential hazard or accident.
Okay, the third one is data login and analysis. The system has the capability to log and store historical CO2 data. This data can be analyzed to identify patterns, trends, or potential sources of CO2 emissions. Through data analysis, the system can provide insight and recommendations for improving safety measures and reducing CO2 emissions.
And next one is integration with existing system. The system is designed to seamlessly integrate with existing monitoring or control system. This integration enables the exchange of data and information, allowing for a holistic approach to monitoring and managing CO2 levels in the environment.
And so the number 5 is the efficiency and reliability. So the system is designed to be energy efficient, ensuring a low power consumption and extended battery life. It is also built to be highly reliable with a long-term stability and minimal maintenance requirement. This can ensure that the system operates consistently and accurately over extended period.
So this is the user interface design. And this is our model, our project model, and the function.
Okay, this is our data analysis of our project. Okay.
So conclusion. The study concludes that the carbon dioxide gas leakage detector is a reliable tool capable of quickly sensing elevated CO2 levels, crucial for safety and environmental consideration. Its significance lies in areas where CO2 is used or stored, like breweries or soft drink plants, ensuring immediate detection of leaks to protect workers and minimize emission. The detectors with operation aids in preventing accident by issuing timely warning or shutting down emitting equipment. Additionally, it serves environmental monitoring by identifying areas where CO2 may escape. In summary, a reliable CO2 detector contributes to worker safety and environmental preservation by detecting and addressing leaks promptly.
That's all from us. Thank you.
Thank you.